simplifying algebraic expressions in order to use the power rule. Alright, so here we want to find the derivative of the following function, and our function is f of x is equal to 2x cubed minus x squared plus 4x minus 1 times x squared. Now, so far based on what we've seen with derivatives, you might think, well, I can just take the derivative of each of the items being multiplied, meaning f prime of x is just going to be the derivative of 2x cubed minus x squared plus 4x minus 1 times the derivative of x squared. And if you did that, you would be 100% incorrect. And let's chat about why. Well, unfortunately, product and quotients don't work like addition and subtraction. If we have the derivative of f of x times g of x, that is not equal to the derivative of its two parts. So we cannot break apart multiplication like addition. Similarly, we can't break apart division like we did subtraction. So the derivative of f of x divided by g of x is not the derivative of f of x divided by the derivative of g of x. So since we can't pull apart products and quotients to find the derivative, we're going to need to find another way. And that other way is to simplify the expression to just get rid of any products or quotients. So let's take a look at how that works. So going back to our original example, since we can't break it apart, we need to get rid of this particular product. Well, going back to algebra, we know that we can take this x squared and we can distribute it in to each term. So we can rewrite our function to be 2x to the fifth minus x to the fourth plus 4x squared minus 1. And again, all we did is we removed the multiplication, and now we have a polynomial with just addition and subtraction, which we can just take the derivative of each term individually. So let's go ahead and do that. So that means f prime of x is going to be 10x to the fourth minus 4x cubed plus 8x plus 0. And we don't really need that plus 0 there, so our derivative is going to be 10x to the fourth minus 4x cubed plus 8x, boom, 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 done. So for these type of problems, again, we just need to use a little bit of algebra to get rid of a product, or potentially a quotient. Alright, next up we want to find the derivative of y equals the quantity 3x squared plus 5 times the quantity x minus 1. And again, we have multiplication here, but unfortunately we can't break that multiplication apart. So we need to do some algebra to get rid of the multiplication, i.e., in this case, we are going to need to FOIL. So after we FOIL, we're going to get 3x cubed minus 3x squared plus 5x minus, So what was that? 3x squared plus 5x minus 1. And now that we got rid of the multiplication and we're left with just addition and subtraction, we can come in and take the derivative. So let's see, let's use some different notation. Let's use the dy over dx notation here. And we're going to get 9x squared minus 6x plus 5. Now the derivative of negative 1 is 0, but we don't need to write 0, so we're just going to leave it as 9x squared minus 6x plus 5. Alright, in our next example, we're being asked to find the derivative of the function negative 3x to the fifth minus x to the fourth minus x cubed plus 4x squared, and that's all over x squared. Unfortunately, though, we do have division. And again, we can't just take the derivative of the top and divide it by the derivative of the bottom. So we got to do some fancy algebra here. Now, there's two different ways you can do that fancy algebra, and I'll show you both of those ways. So the first way is to pull this apart into 4 separate fractions. So we're going to have f of x is equal to negative, let's try that again. F of x is equal to negative 3x to the fifth over x squared minus x to the fourth over x squared minus x cubed over x squared plus 4x squared over x squared. And then we can simplify this down. Let's see, this is going to be negative 3x cubed minus x squared minus x plus 4. And there's a function we can take the derivative of. So again, that's method 1 for simplifying down. And now we're just pulling it apart into 4 individual fractions. Another way is to factor out the greatest common factor from the numerator. What do I mean by that? Well, we can see that each one of the terms in the numerator is going to have an x squared in it. So I can write this as x squared times the quantity, negative 3x cubed minus x squared minus x plus 4, and that's all over x squared. And the reason why this method works is because now we have a factor of x squared in the numerator, a factor of x squared in the denominator, boom, 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 they're gone, leaving us with negative 3x cubed minus x squared minus x plus 4. And here you can see it doesn't matter which method we use, as long as we use it correctly, we will end up with the same simplified expression. And now we can go ahead and we can take the derivative, so f prime of x is going to be negative 9x squared minus 2x minus 1. Boom, boom, boom. And alright folks, that is the end of simplifying algebraic expressions in order to use the power rule.